Today we will discuss about the experimental procedure to conduct the blocked rotor test on three-phase slip ring induction motor. So to conduct the blocked rotor test, so we need a three-phase auto transformer, so one ammeter, voltmeter and two watt meters, and this is the three-phase slip ring induction motor on which we are conducting this experiment. So as we are telling that it is a blocked rotor, so we are conducting blocked rotor test. So before starting the experiment, we need to ensure that whether the rotor is blocked or not. So here I already applied the load. So already I applied around 10 kgs load. So rotor is blocked, so it is not free to rotate. So now if you see the circuit diagram, so this is the circuit diagram. So this is the stator winding and this is the rotor winding. So rotor is short circuited, and for stator I am getting supply from the three phase auto transformer through a voltmeter, ammeter and two watt meters. Now let us look into the circuit diagram. See, this is the RY supply, RYB phases I am giving to the input to the three phase auto transformer. The variable output terminals R, Y and B. So these three are the variable output terminals. These three are the variable output terminals. So this is R and this is Y and this is B. So I am connecting R phase to the ammeter common, and other terminal I am connecting to the M of the wattmeter 1. I am shorting the MC terminals, and L I am directly connecting to the A1. A1 of the slip ring induction motor, A1 stator terminal of the slip ring induction motor. And next, for this wattmeter I am getting supply from B phase. So from variable output B phase I am connecting to the wattmeter 2, and MC is shorted, and L is connected to the C1 terminal of the slip ring induction motor. And for B1 terminal, so I am directly connecting it to the yellow phase, Y phase. Okay. So for this I am connecting two voltage terminals of the wattmeter. Here I am using 300 volts voltage terminal. I am directly shorting. I am giving this connection to the Y phase of the auto transformer. Same, this common point I am connecting to the B1 of the slip ring induction motor, and I am connecting voltmeter across any phases of output terminals of the three phase auto transformer. So I can either connect that voltmeter across RY or RB. So this is the connection diagram. So here before conducting the experiment, so we need to ensure the dimmer position, three phase auto transformer position is at minimum or not. So this we must be taken one of the precaution. So now it is at minimum position. So if we see the experimental procedure, so first of all we need to close the TPST switch, and we need to apply the voltage slowly. As the machine is blocked, it will draw heavy current from the supply. That's why we need to apply the voltage until the rated current flows through the machine. That reading has to be noted down. So now we will start the machine. So dimmer position is at 0. So I am closing the TPST switch. Now I will slowly apply the voltage. As the rated voltage of the machine is 7.5 ampere, I am varying the three phase dimmer until 7.5 amperes current flows through the machine. Okay, so ammeter is deflected 7.5 amperes, ammeter pointer deflected up to 7.5 ampere, so which is the rated current of the slip ring induction motor. So if you see the voltage, so it is around 65 amperes. So for 65 volts, for 65 volts, so I am getting 7.5 amperes, and we need to measure the two wattmeter readings. So one wattmeter is showing around 380 watts, and another wattmeter, so it is deflected in negative direction. So other wattmeter it's not responding. Okay, so it is giving around okay, it is giving around 40 watts. So minus 40 watts. So first wattmeter is deflecting minus 40 watts, and second wattmeter is deflected up to 380 watts. So only one reading is sufficient for this experiment. So we need to take the voltmeter reading, so 65 volts, ammeter reading, so this is the short circuit current, 7.5 ampere we got, and W1 we got minus 40 watts, and W2 we got plus 380 watts. So this reading has to be noted, and we need to draw the circle diagram. So this is the model graph circle diagram. So by no load test we will get some data, and from blocked rotor test also we'll get some data. By combining the two data, so we will plot the circle diagram. So this is the experimental procedure to conduct the blocked rotor test. To stop the mission, again I need to reduce the variac. I am reducing the voltage, so 0, reducing the voltage to 0, current also reduce it to 0. Now I can open the TPST switch. Need to conduct the experiment. Stop.